Hi, everyone. Thanks so much for coming for our webinar. I just want to extend a special thanks to everybody from all over the world who's coming to us from different time zones. And so some of you are really early and really late, so I want to say thank you for that. So today's topic is MQTT with OGC SensorThings API. And Steve Liang, Dr. Steve Liang of the University of Calgary is going to be going over the topic with you. Steve's been working with OGC SWE, that is OGC Sensor Web Enablement Standards, for over a decade, and is the author-editor of the SensorThings standard. He's also a geomatics professor as well as the founder and CEO of SensorUp. So you're going to be getting a very good introduction to MQTT and SensorThings from an expert on the topic, and I hope it's really useful for you. Just a few housekeeping items. If you move your mouse to the edge of your screen, top or bottom, you should see a Q&A panel. If you click on Q&A, you can ask questions in there, and we'd love to have your questions. Please go ahead and ask them, and we will answer them live at the end of the talk. And then if there's anything you want to bring up, please click on the chat button. And if you click on that now, you'll see that I've put the links into where we're posting the webinar recording, as well as where we're posting the webinar slides when they're ready, as well as the link to next week's webinar. So please don't forget that you do need to register for each webinar, including next week's, and we'd love to see you next Thursday as well. So now that all of that is taken care of, we can get started on the real thing. So I'll hand it over to Steve now, and he'll take it from there.
Thank you very much, Carl, and thank you all for coming for this webinar. And definitely from the list of attendees, I think MQTT is a topic that attracts a lot of people's attention. And indeed, it's something very, very nice. Actually, it's a good technology and has been used very, very widely. So let's dive into the details. Okay. So a little bit about me. I'm a professor and founder and CEO of SensorUp, and I have a company called SensorUp. So actually, we were interviewed by a newspaper yesterday, and they asked, why are we doing this, right? So I just want to share our vision. We firmly believe in a open, interoperable Internet of Things or sensor web. We believe the real potential of IoT or sensor web is about mix and match. It's about how can you mix and match different sensors for innovative applications. So we strive to reduce the friction so that you can easily innovate by putting different things and geospatial information together. And so that's what we do. And part of the solution is the standard. That's my research. And part of the solution is the code, the software implementation. So we provide at SensorUp, we provide we believe the most complete and most comprehensive SensorThings API solution. Yeah, and we are also proud member of Eclipse and Open Geospatial Consortium. So some news, again, I mentioned about last week, but also do it this week again. We proposed a new Eclipse open source project called Whiskers, and we will implement a client library for SensorThings API, as well as a lightweight SensorThings API server in this open source project. Of course, it will include MQTT support. Actually, MQTT is kind of addictive. Once you start using it, it was like, who needs HTTP? Okay, I'm joking. I mean, they have different parts. HTTP play a nice role, and MQTT play a nice role, and we'll talk about it later. And so again, Whiskers is a JavaScript library client side at the moment, and we do intend to expand to other languages like Java, C, or you can name it, or you can tell us what the kind of library you want to see, and the lightweight SensorThings server for IoT gateways. And first release expect Q2 2016. Yep. Okay, so what will be covered today? First is MQTT. So what is MQTT? And we'll do some live demo and some practice about what's MQTT. And then based on that, we will explore a SensorThings API MQTT extension. So first of all, the first question is, why do we need it, right? With MQTT, why do we need a SensorThings API extension? And then hopefully I can convince you the marriage of the two is awesome. It's really complement each other. Okay, so the first question before we go into MQTT is, why not HTTP? So why isn't HTTP enough? So first of all, the first bullet point, HTTP sent a request, received a response. Very simple model and what we are very, very used to. However, in IoT or sensors, we have fundamentally different challenges. So the first one is we need event-oriented paradigm. So sensor or IoT exists to detect events. So what's going on? What happened? And so as a result, we need a architecture more for events, so event-oriented. And for example, we need to distribute information from one to many. So when an event happened, it will distribute to many subscribers, right? And who want to know the event happened in near real time. So one to many. And then the clients, the users, the application, analytics, they want to know whenever the events happen. So they want to get notifications whenever they happen. And with the HTTP model, you need to keep sending requests to the server, and which is not very efficient and adding unnecessary load to the server. And the third bullet point, so distributing minimal packets of data in huge volumes. A lot of sensors are very, very small devices and using very costly network like 2.5G, 3G. So how we need a protocols is efficient enough with very, very little overhead. So all the dollars, the cost you spend is on the data itself, but not the headers, right, of the protocol. So that's important. And finally, pushing information over unreliable networks. A lot of networks for IoT are not reliable. You might be in the field. You might be using a very, very low bandwidth and low power network. So they are not reliable. So how to get reliability over unreliable network? It's interesting, right? So we need something different. Next slide. And why isn't HTTP not enough, right? And power consumption is a major concern. So HTTP, the header, unnecessary overhead, really consume power. Although it's not much for a smartphone, look my orange phone, or it's not very much for a laptop or desktop, but it's quite a big overhead for any sensors or battery power devices. And responsiveness, the next bullet point. So the product going to be very, very responsive. So near real-time applications. And finally, scalability. We need an architecture able to scale like 50 billion devices. And again, the efficiency, the low overhead becomes very, very important. So hopefully convince you why HTTP is not enough. So what is MQTT? There are so many protocols, right? Why MQTT? First of all, it's a standard protocol. So MQTT is an ISO standard recently, I think approved this year. And then before ISO standard, it was an OASIS standard. So again, open consensus-based standard. So that's good. That's good. Nobody control it. It used to be IBM thin, but they contribute to the OASIS and ISO. And it's probably the most popular IoT messaging protocol. And then, yeah, developer like it, and efficient and scalable. So next slide. Actually, this is from a slide from the Eclipse IoT Developer Survey last year, 2015. So what are the general messaging protocols the developers use in the IoT solution? So of course, HTTP is the dominating, right? But not surprisingly, actually, not surprisingly, MQTT is not far behind. 53% of people are using MQTT. And you look at CoApp and other stuff, they are just, kind of way behind. So HTTP and MQTT. So definitely these are the two major protocols in messaging protocols in IoT. So of course, in OGC SensorThings API, we provide both because they are the most popular and they are standards. So again, let's look at this. This is a slide about power consumption. So if you compare the power consumption of HTTP, which on the slide is a yellow or orange-ish, and then MQTT is the blue. So you can see actually MQTT consume much less power. So this is much better in terms of power consumption than HTTPS. And next one, I think this slide is even more important, which is reliability. So if you look at this, the part I circled, in a 3G network, if you use HTTP, and then you lose almost 75% of the messages in this scenario, which they send in this test, they send the message as much as possible, right? And for MQTT in a 3G network, and with a very fast, like high frequency to send messages, and they receive every message. So again, it shows that MQTT actually is a reliable protocol. And also, actually, the MQTT also supports security and encryption, so similar to HTTP. So yeah, so just show you that it's really a protocol designed for IoT. So what MQTT is not, right? Because actually I heard a lot of people that said, oh, I'm using MQTT so that my IoT application is interoperable. Oh, come on. It's like you claim you are using HTTP and then you have a 5-star open data. No, it's not. So actually using MQTT doesn't mean IoT interoperability. It's part of the solution. It's a nice solution, but it's just part of it. You still need a data model standard, such as SensorThings API, and to enable data interoperability, because MQTT doesn't care what do you transmit over MQTT. Without a proper data model and the interaction model, and you just cannot, you don't know how to interact with the server or the API, and you don't know how to interpret the data you received, or don't know how to push the data to publish observations, for example. So all these need to be defined on top of MQTT. So that's where the SensorThings API play a nice role here. And then SensorThings API, when we design it, we consider MQTT. So it's a it's a nice design to put them together. Okay, so go to detail about MQTT. In the MQTT, the first concept we want to introduce is called topic. So it's a central concept in MQTT to dispatch messages, and you base on topics, okay? And a topic is a very simple string. You can have more hierarchy levels. That's a very important concept. So you can have different levels, and they are separated by a slash. And for example, let's say topic example, like house / living room / temperature. So that means it's very similar to the REST URL path pattern. So you have used this kind of like a URL-like hierarchical levels. Okay, and the topics serving as the routing information for MQTT broker. So they look at this the topic and look at, okay, who published to this topic and who subscribed to this topic, and then the broker push the message from the publisher to the subscribers according to this topic. Okay, so the simplest one is if the topic fit, right? The publication topic, I publish with this topic, and then I fit to the topic of the subscribers, right? One-to-one mapping, and then they push it, right? That's the most naive way, for example. Okay, so here's some diagram. So first of all, before the subscribers, they can receive anything, they need to subscribe, basically register the topic to the broker. So in this case, for example, with 3 subscribers, and they send it to the broker, say, okay, I'm going to subscribe to topic 1 as a string, topic 1, and so on and so forth. So all of 3 subscribers, they subscribe to topic 1, okay? And after that, whenever a publisher sends a message, and the message has 2 parts. One is the the topic. The other one is the body of message. So whenever the publisher send a message with topic 1, for example, and then the broker will look up. Okay, so who subscribed to this topic? Okay, and then these 3 subscribers, they subscribe to this topic and push to them. So that's basically the interaction model of MQTT. And MQTT basically have the following verbs. The method like HTTP, and the first one is connect, right? So before you can connect to any broker, you need to establish connection to connect. Of course, when you have connect, you have disconnect, right? So bye, I don't need any message anymore, right? So disconnect. And then there's subscribe. So subscribe means I subscribe to a topic, right? So I let you know, okay, I want to know this topic, right? Whenever there's something about this topic, I want to know. Of course, when you have subscribe, you have unsubscribe, right? So I don't want to know anymore, right? So unsubscribe from topics. And finally, you have the publish, right? So publish the message so that the subscribers can receive the message I publish. So these are the methods from MQTT. So definitely it's different from the HTTP, right? The create, the post, the get, patch, delete. So that's the MQTT method. So let's give it a try. I put two links here. The first link is a HiveMQ. That's a nice WebSocket-based client. The link is there, and we'll use it later. But right now I use a open source tool called Mosquito, and then there's some code over there. But let's look at this. Okay, so Mosquito. So I put some code here. Very simple. I'm going to use my terminals. Okay, so let's look at this. So first, let's subscribe something. So let's look at this line of code. So this is the Mosquito sub and -t. That means the topics I'm going to subscribe. So in this case, I'm going to subscribe house. And then the host, which is the server address, is the iot.eclipse.org. That's the sandbox server from Eclipse. So let me do this. So Mosquito sub -t house. So I'm subscribed to the topic house. Okay. So right now I'm subscribing to it. So let's publish something to this topic and see if we are going to receive anything. So I'm going to publish a message. It's called hello. Okay. So when I publish to this topic with hello, and I receive the message, right? So I can do it. Yeah, like I received that in near real time. That's nice. Not very interesting anyway. So, but it shows you the idea. So, for example, let me publish to the other topic. Let's say I publish to house 2, for example, and okay, of course, the window on the top didn't receive it, right? Okay. So I think that's the idea. So of course I can change the message as well. So for example, I change to it's the same topic, and I said hello, Steve. Okay. So what happened? Hello, Steve. Yes, hello, Steve. Okay. 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 Great. And let's look at this. Let's look at this. Let's do something more interesting. So this is a counter. So we have 75 in this case, and then it's count down, right, from 75, and then keep publishing the messages. Okay. So for example, we can do this. Let's Mosquito publish. For example, okay, this is a counter. This is the code I just showed you. Let's count down from 1,000. And then so, okay, so let's publishing it. And then, oh, sorry, bash Mosquito publish. So let's publish it. And let's subscribe to it. Okay. Let's do it again. So sorry, Eclipse, I'm trashing your server. Low, and then host is iot.eclipse.org. Okay. So let me see. Which house? Sorry, I need to subscribe to house. Okay, house. Okay, so you can see, the counter is keeping counting down, but right now, my script is pushing this message over the MQTT. Okay, you get the idea. And then, great. Next. So that's the basic of MQTT. Very, very simple. Okay, MQTT topics continue. So actually, one of the very powerful features for MQTT is the wildcard. So provide some query capability or matching. It's a matching. So there are two wildcards. So one is plus sign. So plus sign is a single level wildcard. So for example, if you look at the example I show you, subscription of a house / plus sign / temperature will receive messages published to both, like house living room temperature and house bedroom temperature. So you have the wildcard in between, right? Just for that level. So single level wildcard. And the pound sign or dollars, the number sign is a multi-level wildcard. So for example, if I subscribe to house / a number sign, and it's subscribed to any topic begins with the house topic. So for example, if I subscribe to just the topic of number sign, you will receive all messages sent to this MQTT broker. So let's see what kind of interesting topics or messages people send to Eclipse. This is interesting. So let's say let's put the number sign here. So in this case, is I subscribe. The topic is everything, right? I want to receive everything from this IoT Eclipse sandbox, and then go. Okay, as you can see, it's a very busy server. You can also see actually the performance of oh, even Korean over there. You can also see that the performance of MQTT, it's quite nice, right? Yeah, okay. I think that's enough. But if we can, for example, let's say we do like house, this, maybe how about this? House temperature, okay? And do this. And let's publish something. Let's say, let's go pub house. So let's publish this house. Let's say bedroom and temperature. Okay. So are we going to receive the message here? Because according to wildcard, so the middle one is bedroom, and here I use the wildcard. So supposedly I will receive when I publish this hello, and then I should be able to receive the publication. So let's see. See, okay, it's here. Great. So the wildcard works. So it shows you the wildcard, right? So okay, good. Let's move on. Okay. So that's the wildcard. So again, further explain what's a wildcard. So subscribe to 3 different topics, and then and when the publisher you send, in this case the topic's HBT, and so the first subscriber, because using the single level wildcard, so it will receive the message, and then the second subscriber also use the single level wildcard at the 3rd level, so HB plus, so HBT fit match at HB plus, so yes. However, the last subscriber subscribed to exact topic of HBS, and because the publishers published to HBT, so no, not a match. So he or she won't receive the message. Okay, so similar idea. So if I change my topic to HAT, and in this case, the first subscriber will still get it because it subscribed to, it fits, it matched the H wildcard T, right? And the rest of 2, they don't. Okay. Okay, there's one more concept from MQTT. It's called quality of service. So they have 3 different quality of service level. The first one is fire and forget. So they just fire it out, and then no guarantees they will receive it. Okay, so there's the other one is called deliver at least once. So the broker stores messages on disk and retries until clients have not acknowledged their delivery, right? So all the subscribers say, okay, I got it, right? So, but it's possible when the client, the subscriber, they send the acknowledgement and then the broker never receive it. So it's possibly with duplicates. So that's a QoS1. The second level, the next level is QoS2, is deliver exact once. So of course you can see there might be a big overhead. So QoS2, but at least MQTT allow you to have some guarantee. Depends on your application, right? So for example, if you have a doorbell, and then you click, you press the doorbell. Actually, QoS 0 is good, right? If you miss it, it's not a big deal. But if it's something very, very important, right, and then important event you want to publish, and you might want to consider QoS 2. So what's not included in MQTT? So first one, what does the topic mean? HPT, HBS, but even house living room temperature. I mean, what do they mean, right? Really, it need to be defined, and it's missing, and it's not part of the scope of MQTT. And the second part is how to interpret the data pushed to you, right? The good solution or great solution will say, whenever you look at the topic, and you should know how to interpret the data, right? And that's how SensorThings API works here. So SensorThings MQTT extension, that's define the URL pattern. That means you know how to construct your topic and how to interpret your topic. So the URL path tells you how to find the metadata. Just by looking the URL path, and you can, that's the topic I subscribe to. However, if I want to know more about this, the metadata about these entities, right, like observations or sensors, and you can use fire HTTP. HTTP is great for static information. So fire HTTP, and you can get all the metadata, right? So use MQTT for the real-time updates, and use HTTP to get the relatively static metadata, right? And it's well defined. So by the topic, you know how to get it, and you know how to interpret it. And so the entity names tell you how to interpret the data. If it's a sensor, you know sensor. If it's observation, yeah, it's fit into observation data model, right? So it's a very nice design. So for example, in this case, it's a very typical, almost, maybe the most used subscribe topic is I want to subscribe to a data stream and all the observations from this data stream. So this is the example I show you. And then also, by the way, we also consider the version number. So that's why V1.0 is at the front, right? Because in the future, there might be a different version with SensorThings, right? So in this case, you get the observations from this topic. Okay, you know what? Let's give it a try. So this time I'm going to use this Hive MQ, and this is a SensorThings MQTT. So first of all, let's subscribe the topic. So in this case, I subscribe V1.0 first version, and then data stream and the ID and / observations, like this, exactly like this. Okay, so data stream observations, and right now let me publish the data like result 50. Let's change it. Let's say 99, right? 88. Chinese like this number. It's a good number. Okay, so I publish it. So supposedly I will receive 88 here. Okay, but before I publish it, I also want to show you that I have a client here. Actually, this is a SensorUp dashboard for our SensorThings API. So it's an administrative dashboard, allow you to manage the assets and entities of this server. And I subscribe to MQTT here. So supposedly when I insert the new data, and then it will also show up here. So with one subscriber here and the other subscriber down below here. So let's publish, and then it's received here, and then it's also received here, for example, right? So get pushed to it. So it's quite nice. For example, like that's 99, it publish here, and at the same time, it publish here too. Okay, so just show you how it works in this. And I think I have a little script here. Let me see. Let me confirm. Yeah. So I'm going to publish. I send a lot of observations to this SensorThings API, and let's see what's going to happen. So as you can see over here, we get the real-time readings and through MQTT, and then the dashboard can receive it. And here it should also go crazy. it's like this, right? So receive it. So as you can see, it's very, very nice. And actually, the code footprint is very, very small. So very, very efficient. Especially if you're familiar with SOS, this is very efficient, actually. Very easy to use. And in our own experiment, actually, we tried both HTTP to upload data with HTTP in RESTful JSON, SensorThings, and MQTT. And actually, HTTP with a very high frequency, you kill the phone very, very soon. I mean, you overwhelm the phone. But MQTT is just reliable and stable, right? And it's not even talking about using the SOAP from of the SOS. I mean, that's just, I mean, don't use it. Okay, don't use it. Anyways, okay. So here are some. If UML is your thing, that's your sequential diagram. So actually, the other very nice consideration in SensorThings is no matter you publish through POST or through MQTT, you can also get the data through MQTT. So for example, the first step, subscribe to a topic, and then whenever a sensor or a user a post create a new observation, right, and it get pushed to MQTT topic as well. Or if the sensor, the last line there, the publish an observation, that means you create a new observation through MQTT, and it also pushed observation through MQTT. So it's a really nice bridge between the two. So no matter the sensor is using HTTP or MQTT, it doesn't matter. And for the subscriber, you can use HTTP or MQTT. It doesn't matter. So next one is but not only about observations. We have use cases like this, right? How do I know if there's any new thing join the SensorThings API, the system, right? For example, in some cases like smart home, right? I put a new device, like new thermostat in my home. How do I know they are added, right? And then, or in an emergency response scenario, I'm putting like 100 sensors right now because there's an emergency. And how does the first responders or the servers or even the catalog, they know, okay, 100 sensors has been deployed, and two more observed property has been created because for this scenario. And MQTT is also very good for this, right? So in this sequential diagram, if you look at it, so first you subscribe to it, okay? And second, if somebody create a new entity, let's say register a new sensor, and then this will be pushed through MQTT. So it's not only about observations, it's about all the entities in the SensorThings, and you can get notification out of it. So this can be very, very useful. And you don't need to repeatedly request and respond, right? You only get a new one when it's up. Okay, I'm going to show a demo. It depends on our bandwidth. I don't know if you can see the video very smoothly, but I will publish the link. So right now you can see a sensor register itself, and so it announces itself, and then the registration get the creation of this sensor get published through MQTT. So the map can see the icons pop up, right? And also, we can subscribe to the readings from these sensors. So as you can see, it's a very nice design, and you can really set up a sensor, and then it automatically, because all following standards, so automatically the client will know, okay, these are the new sensors pop up, and then these are the new readings. I can subscribe to it, and then no matter where are these sensors from, right? They can from different main vendors, as long as they speak SensorThings MQTT or SensorThings, and it will show up in this dashboard client. Which this one is a different client we developed in SensorUp. Okay, so summary, hopefully I provide some useful information. So MQTT is very suitable for IoT, and I strongly recommend you to use it for the reasons I mentioned above. The test result actually explain itself, right? And SensorThings API provide the greatness of both HTTP and MQTT. And HTTP REST is suitable for historical data and analytics. Right, you want to retrieve, you want to filter, you want to apply some like geofencing filter, right? For example, and MQTT is very suitable for real-time applications, and so the marriage of the two is great. And SensorThings API is designed to have these two seamlessly working together. So these are references you can read for the future, and then come back next week. So hopefully it's useful. And then any questions?
Okay, everyone. So while we're waiting for questions, and once again, if you put your cursor on either the top or bottom or side of your screen, you'll find the Q&A panel, and we'd love to see your questions there. While we're waiting for questions, if you wouldn't mind answering the poll, just a 2-question feedback survey that I'm launching right now, and you should see right away. That'll give you something to do while we wait for questions. We do have a first one in here now. So how does MQTT work in the face of disruption or low bandwidth?
Okay, so MQTT the design is very, very efficient. Like the header, it's down to the byte. So what's the for the first bit and first byte, and then what does that mean? So it's not like HTTP. They use the text as the header, and then they used the design of MQTT is really like, how can we make this overhead as small as possible, right? And like acknowledgement is down to like 2 bytes, I think, or one byte. So it's very, very efficient. So that's why it can be used for very low bandwidth and unreliable network. And also they have this QoS, the quality of service design, right? So when it's not reliable, and it depends on your use case. You can say, okay, it's too unreliable, right? So I need to use QoS 1. So at least the client, I'll ensure they receive the message. Hopefully answer your question.
Okay, so I'm going to repost the links to where we're going to put the recording and where we're going to put the slides and where we're going to put the link to next week's webinar, because I have somebody telling me that they're not actually up. So I'll be reposting those in a second. We just have a couple more questions to get to first. So first of all, how do you think the competition between MQTT and HTTP will play out in the long run? Ooh.
It's not a competition, actually. As I said, they complement each other. Actually, MQTT is for push, so different paradigm. MQTT is event-driven, and HTTP is not. It's request and response. So it's great for queries, right? MQTT, I don't think you use MQTT to do queries, right? To filter, for example, filter. No, you don't use MQTT to do that. You use HTTP. So they define differently, and definitely HTTP provides you the big header file, provides you much richer semantics over there as well, right? So it's different. It's a different tool. It's fit for use. So that's why I don't see a competition. I see it's more like complement to each other. But maybe the other question is how about MQTT and CoAP? So CoAP is the other IoT messaging protocol, which is more like a HTTP, but it's a very, very efficient HTTP. So again, similar design principle, how to shrink HTTP down to like very, very minimal, so that you can use for constrained devices and constrained network. So that might be something interesting. And then also CoAP, again, they use something, they are like HTTP, so it's a request response model. However, CoAP has something called a method called observe. So it's like you can observe the changes of some entities. So that's interesting. So we don't know about MQTT and CoAP, which one will go, grow faster. But currently, MQTT is still has the major market, I would say. But I would encourage you to look at CoAP as well. And of course, SensorThings support CoAP, and we do design to incorporate these IoT protocols.
Okay, so the next question actually touches on what Steve just brought up. So the question is, how does it being MQTT compare to CoAP?
I think I briefly mentioned about it. So CoAP and MQTT, again, CoAP is request response model, right? And CoAP go UDP, and MQTT right now still TCP, so UDP is more efficient, but TCP more reliable anyways. But also MQTT has a profile called, or extension called MQTT Sensor Network, MQTT SN, that's UDP. So actually I would say the two are very, very similar. Yeah, they are very, very similar. But MQTT is more proven technology. It's very, very scalable. The brokers can handle lots of messages, right? So it depends on your application. I would say MQTT might be your first choice because it's proven more, it's proven technology. And CoApp looks good. However, the implementations, you know, they don't have such a big ecosystem like MQTT yet. Yeah.
Okay, so our next question is if you use QoS-2 and the client never acknowledges, will SensorThings handle that gracefully?
Oh, yes, and the MQTT will do that, right? So basically, it just the server will just keep trying, right? The MQTT broker will store the message and just keep trying until it cannot acknowledge it, right? And I think there are some settings we can do. So how long you are going to give up? There are some settings we can do. Yes, and we do handle that. And actually, just something I didn't mention today. Actually, maybe I can show you. I was thinking to don't do too much information. Okay, this slide. Don't skip. It's called retain. So MQTT also has these functions called retain. So if the message has a retain flag, so indicating it should be stored for delivery for new subscribers, and then it will broker will do that. So sometimes, for example, when I show you the examples I use, when I subscribe to a new topic, and at the beginning it's empty, nothing, right? But if I publish a message with a retain flag, and then so whenever I get subscribe to that topic, I will get this like the message retained, so it will push to me. Yeah, so this is something also built in an MQTT function. Okay, FYI. Any more questions?
Yes, we have actually quite a few questions. So the next one is, can you use MQTT to talk back to the sensor?
Yes. Yes, because a sensor can subscribe to a topic, and the topic could be a task, right? A tasking channel, right? For example, subscribe to this topic, and they just tell me to turn, right? And the answer is yes. So the question becomes, what is the semantics of it? And then, as you know, in SensorThings, tasking is our next step. So definitely, when we design the tasking profile, the part 2 of SensorThings, we will consider that. So the sensors can use MQTT to receive the tasks, right? To talk back to the sensor. And the answer is yes. And then if you're interested, join the meetings, yeah? The standard, the meetings we discuss the standards, right? And let your voice to be heard.
All right. So we have 3 more questions, but we welcome more if you can think of them while we're answering these. So the next question is, how about MQTT versus ActiveMQ?
Oh, I'm not an expert in ActiveMQ. I used it. There are some libraries that support everything, right? And then, so I cannot tell you the details. I mean, the feature comparison. I can tell you something, which is ActiveMQ. If you look at the market share here on this slide, MQTT is much more dominant. It's more popular. And if I'm not wrong, I think ActiveMQ or AMQP, it's not an open standard. It's from Apache, right? It's open source, but it's not a specification maintained by ISO, for example. Correct me if I'm wrong. I might be wrong, actually, on this case. But definitely MQTT is ISO Oasis standard, so it's consensus-based. It's properly governed. Next one.
So we have another question. It's, could you please discuss any examples of retrofitting large legacy sensor networks to use the MQTT protocol?
Retrofit. That's a big question. So first of all is, does your sensor network already support speaking TCP/IP, for example, or UDP? And then if yes, and you can install the code on your sensors, right? But in many cases, actually, the sensors, when they talk to And they don't directly talk to the outside world, right? They talk to a gateway. So the more popular way to do it is you on your gateway device, and you use MQTT to talk to the outside world. And then from your gateway to talk to your sensor networks, you use whatever networks you are using. For example, it could be a mesh network, could be ANT plus, can be BLE, ZigBee, so on and so forth, and 6LoWPAN. But on your gateway, and you talk in MQTT. So in this case, you just add one more module to your gateway device, the MQTT support. So I think that's the most common method to do it, and it's our preferred approach. And then, well, promotion. I think in Eclipse IoT, they have a library called Cura, and it supports MQTT as well. It's a software for gateway devices. So I encourage you to look at it.
All right, so I have one final question, but we do welcome more if you guys think of any. So this question is, in the message comparison slide, more messages were sent via MQTT than HTTP. Even though the energy per message is lower for MQTT than HTTP, isn't more energy consumed with MQTT to complete transfer of the 1,024 messages?
Not really. Actually, if we look at this slide, right? If you look at, okay. So first of all, I think if you read the blog post, it's somebody did the experiment. Actually, he mentioned this test actually is not, what can I say? Okay, it doesn't consider one thing, which is to keep a live message. So there's overhead as long as you want to keep alive, so let the server know I'm alive and you can send message to me, right? And so there's overhead over there. Okay, but anyways, if you look at this, in MQTT, you send much more, right? So it's like 160,000 messages. And because that's a limit, it's the best effort, right? You try to send as many as possible. And it uses about 16% of the power. And in HTTP, that's the most you can send. And then they use about 18% in 3G. And using Wi-Fi, MQTT is able to send more, okay? And then per hour. And then use 4.23%. So more power consumed, but much more messages, right? So if you look at average battery usage per message, MQTT is much lower. But again, this is not a normal use case. Normally, you don't do that, right? Yeah. Normally don't do that. But basically, this is the focus of this is the reliability. So MQTT, even in a 3G unreliable network, and you can receive when you send 1,000, you receive 1,000. When you send 1,000 in 3G, you lose 75%. I think this is the main message from this slide, actually.
Okay, so that completes all of our questions, and thanks so much for those, guys. We really appreciate it. Thank you also to those of you who answered the poll. I really appreciate that as well. And I look forward to hearing from those of you who promised to email me your comments. Those will be exciting. Please check your chat panel. We have the links there for next week's webinar. You must register for it as well. And we would really love to see you there. We're going to be going over putting it all together. So everything we've talked about in the last 3 weeks, we're going to put together and give you a nice sum up. And I noticed that in our poll, a lot of people asked for use cases. So we'll try to put even more of those in for you next time. I've also got in the chat panel the link to where we're posting the webinar recordings and where we're posting the webinar slides. So there's some great links in there. I think I might have another question. I do. The SensorThings API mandates the use of JSON payload, apparently. Doesn't this kind of ruin the benefits of MQTT's high bandwidth efficiency?
No. No, actually, there's some topics I didn't talk about today. Actually, we have a very efficient way to, let me show you. We have a very efficient way to send data through MQTT. Is like this. Here. So we have this way in the spec is you can, when you define your MQTT topic like this, so you embed this select result phenomenon time, and then that is your return. So as you can see, this is very, very efficient. And actually, we are thinking about the other way to keep it even more efficient is to only get the value of the properties interest you. But right now, the current spec didn't cover that. But maybe we will, if the working group like the idea, and we might add it. So instead of you have result 19.19, 1919. Oh no, well, yes, 19, and then you only receive the value. Okay, but of course, if you become that compact, you lose some semantics, right? But again, the semantics can be found, the meaning can be found from this topic. So yes, so the answer is no. We do consider about make it very, very efficient, and because of the SensorThings design, URL pattern design, we are able to make it very efficient without making some proprietary, like this is the proprietary URL designed specifically for MQTT. No, every URL here in the SensorThings MQTT, you can just change to HTTP and you will get the same answer. Yeah. So I think it's a nice design, right? So no confusion there. Yeah, it's no proprietary or a MQTT. The MQTT extension is not something specific. No, it applies to HTTP as well. So when you write a client, actually, you just swap the binding, and then you don't need to change in any other things, right? The topic is the same, and the payload is the same, right? It just changed the binding. I think that's a great design for SensorThings.
All right, so we have one more question, and that is, how is authentication handled?
In MQTT, they have authentication. If you go to the spec, they do have authentication, the username, for example, the username and password. And they have other different ways you can apply on top of it. It's built in the MQTT spec. Maybe here. Let me see. Yeah, it's built in there. Yeah, in the MQTT. So SensorThings doesn't handle that. Yeah, but it's there. Go check it out. And encryption as well. It supports encryption.
Okay, so that looks like it's all of our questions. So that said, we'd love to see you guys next week. Thank you so much for being here this week. We really appreciate it. We really appreciate all your questions, and we look forward to another lively discussion next week. Check your chat panel for the link. Thanks, guys.
Thank you very much. Bye.